Welcome back to the deep dive. Today, we're we're opening up a topic that I think is quietly causing a bit of a panic attack in engineering departments everywhere. It's this weird paradox we're living in. On one hand, you have these AI models that are just absolute wizards at writing code.
Oh, yeah.
You ask for a website, you get a website. It feels like magic.
It's the sugar high of the generative AI era, right? Instant gratification.
Exactly. But then the crash hits.
Hmm.
Because we're all realizing that, okay, just because an AI can write 5,000 lines of Python in 30 seconds doesn't mean we have any idea what those 5,000 lines are actually doing. We're building these massive black boxes of functionality.
And the moment something breaks, you realize you didn't build software. You just accumulated technical debt at the speed of light.
That is the perfect way to frame it.
Yeah, and the sources we're looking at today, specifically some really deep technical breakdowns from LIDR and the documentation from a framework called OpenSpec, they argue we were approaching a crisis point. They call it the code explosion.
Yeah.
The code explosion. And the solution they're proposing isn't just, write better prompts. They're introducing a whole methodology called Spec-Driven Development, or SDD.
Right.
And the core concept here, the thing we are going to unpack, is this idea of the contract.
Exactly. And contract isn't just a metaphor here. It's a literal mechanism. The whole argument is that we need to stop treating AI like a junior developer we're just chatting with
Yeah.
and start treating it like a contractor we are legally binding to a very specific outcome.
So the mission for this deep dive is to explore how that shift happens. We're going to look at why the code explosion is so dangerous, how you turn a vague 4-line feature request into a bulletproof 1,000-line technical doc?
1,000 lines. Yeah.
And why this might actually mean the end of humans reading code altogether.
It's a bold claim, but when you look at how this works, it really holds up. Okay, let's start with that problem context, the code explosion. The sources make this really interesting comparison between the pre-AI world and now. They argue that historically bad code was limited by physics.
It sounds funny, but it's completely true. Before AI, the bottleneck for creating software, and by extension for creating bugs, was human typing speed and human cognitive load.
Right.
You could only create a mess as fast as your fingers could move and your brain could process syntax. There was a sort of natural friction there.
Right. If I wanted to write a spaghetti code disaster, it would still take me all week.
Exactly. But AI removes that friction completely. The barrier to generating code has dropped to pretty much zero. You can generate a whole microservice architecture in the time it takes to sip your coffee.
Wow.
And the sources point out, if you have exponential growth in lines of code, but your ability to check that code stays linear, well, you have a huge problem.
You end up with an explosion of incoherent code, a mountain of software that runs technically, but is completely unmaintainable because nobody knows the intent behind it.
And that is where spec-driven development comes in to stop the bleeding. The definition is very specific. It's the creation of clear, formal, and exhaustive specifications before a single line of implementation code is written.
Okay, now, I know what some listeners are thinking. Wait a minute, isn't that just waterfall? Isn't that the old 1990s way of planning everything before you build?
It looks like it on the surface, I get that, but the execution is totally different. In waterfall, humans wrote specs for other humans to read and interpret.
And humans are bad at interpreting specs. We make assumptions, we skip the boring parts.
We do. In SDD, the spec acts as a binding contract for the AI.
Ah, that's the key distinction. So the developer's role shifts. We aren't the translators anymore. We're not taking a business idea and trying to remember the syntax for a for loop in Rust.
No. The developer becomes the architect of the contract. You design the spec, the AI implements it, and this is the part that really caught my attention, the AI helps validate its own work against that same contract.
It provides traceability. So if the code doesn't match the spec, it's just rejected. It's not a creative difference. It's a breach of contract.
Exactly. It moves us from a world of prompt and pray to a world of specify and verify.
I want to get into the weeds of what this looks like because the sources gave this incredible example of the 1,000-line ticket. This, for me, really crystallized the whole workflow.
This is the heart of the SDD process. It tackles the most common friction point in software development.
Yeah.
The vague request.
Oh, we've all been there. You get a ticket in Jira or whatever. It's from a product manager who's in a rush. It just says, as a user, I want to edit job positions.
And maybe, if you're lucky, it says, add a button to save. And that's it. 3 sentences.
And then the developer has to play detective, right? You have to go ask, what's the character limit on the title? Can the salary be negative? What happens if the internet cuts out? Or more likely, you just guess.
And you guess wrong, and you have a bug. But in this STD workflow, you don't start coding from those 3 sentences. You take that vague request and you run it through an AI command they call enrichment.
Enrichment. I love that term. It sounds like you're fortifying cereal or something, but what you're really doing is contextualizing the request.
Precisely. The sources describe a scenario where that 4-line user story is fed into the system, and what comes back is a 1,000-line technical document.
1,000 lines. Okay, break that down. What on earth is in those 1,000 lines? It can't just be fluff.
It's the opposite of fluff. It's pure architectural context. The AI looks at your database schema. It sees, okay, the title column is a varchar 100. So the spec explicitly says, must validate title length is under 100 characters. It looks at security protocols. It outlines the exact API endpoints, naming conventions, schemas, response types.
So it's doing the due diligence that a human developer should do but often forgets to do because we're tired or we're rushing.
Yes, and it defines the happy path, what happens when it all goes right. But more importantly, it defines every single edge case. What if the user enters a start date that's in the past? What if the salary minimum is higher than the maximum?
So the task becomes self-contained.
Yeah.
The developer doesn't have to stop mid-sprint to set up a meeting to ask about error messages.
Right.
Because the contract has already defined them.
Exactly. You avoid all those little clarifying questions that just kill momentum. If the AI or the human builds something that contradicts line 840 of the spec, it's wrong. Period.
That is a massive efficiency gain. But handling a 1,000-line document, that sounds like a nightmare if you're just using a text editor. You can't manage that manually.
No, and you don't. That's why the tooling is so critical. The source material spent a good amount of time comparing the different frameworks out there for this. They look at Spec Kit, BMAT, and OpenSpec.
It really felt like a Goldilocks analysis. You know, some were too hot, some were too cold.
That's a great analogy. Let's look at Spec Kit first. That's the GitHub native solution.
Which usually means it's solid, reliable.
It is. But the analysis points out a really specific limitation. Spec Kit is fantastic for greenfield projects. If you're a startup founder building your MVP from absolute zero, it's great. It sets up a clean folder structure. It assumes you have nothing.
But the reality is most of us aren't building from zero. We're working on brownfield projects. We're at a bank or a SaaS company that's 5 years old. We have this huge, messy code base.
Exactly. With legacy code from developers who quit 3 years ago. And Spec Kit, well, it struggles to weave new specs into that old, messy rug. It's a bit too rigid for that.
Okay, so then they looked at BMAT, and the phrase they used for this one was killing flies with cannonballs.
BMAT is the heavyweight champion. It's incredibly powerful. It spins up multiple AI agents. You have a UX agent, a product agent, a back-end agent, all talking to each other.
Which sounds cool, but it also sounds like a lot of overhead.
It's massive overhead. If you're a single developer or a small team, the setup time and the complexity of managing all those agents is just too much friction. You'd end up spending more time managing the tool than building the software.
So that brings us to the winner, at least according to this analysis, OpenSpec. Why is this the just right solution?
OpenSpec wins on flexibility and, I think, reality. It's designed specifically to handle deltas.
Deltas, meaning changes to existing systems.
Right. It excels at taking an existing feature in a legacy code base and managing an update to it. It creates a clear history of changes, so you have a paper trail of how the spec has evolved with the code. It's lightweight enough that you don't need a PhD in prompt engineering to start using it, but it's robust enough for a real-world project.
It makes sure the spec evolves with the code instead of becoming this dead document that nobody looks at after the first week.
Exactly.
Okay, I want to pivot to the concrete demo they walked through.
Yeah.
Because theory is great, but I want to see how this actually works when rubber meets road. They walked through building a talent management system, so basically a big applicant tracking system.
Right. And the specific task they chose was deceptively simple. The product owner wants a button to update a position.
Step 1 in this process is fascinating to me because it involves zero coding. It's the plan backticket command.
Yes. The AI generates what's called a plan file.
Yeah.
In the demo, this file was about 550 lines of English and pseudocode.
And this is where the human developer comes back into the picture. And the sources were really emphatic about this. The developer's job is to read every single line of that plan.
This is the pivot point for the entire profession, I think. You are not typing syntax anymore. So your entire cognitive load Shifts to verifying logic. You have to ask,
Huh.
does this plan match reality?
Give us an example of what that check looks like.
So, in the demo, the plan said, validate that the title field is under 100 characters. The developer needs to then go look at the actual database schema. If the database column is set to varchar 200, but the spec says 100, you have a conflict.
You have a bug.
You have a bug.
Yeah.
But, and this is the magic, you caught the bug in the design phase. You caught it before a single line of code was ever written.
That is the definition of shifting left, moving quality control earlier in the timeline. So once the human signs off on the plan, basically signs the contract, what happens next?
Step 2 is develop backend. The AI just executes the plan, it creates the branch, it writes the controller, the service layer, the validators, the routes. It does all the typing.
And then step 3. And honestly, this was the moment where my jaw hit the floor. Verification.
This is the game changer. In that demo, the AI automatically generated 68 unit tests for that one update position feature.
68 tests. I have to be honest, if I'm manually coding a feature like that, I might write, 3? Does it click? Does it save? Does it crash if I do something dumb? That's about it.
And that's what the source is called the zero cost of quality. Historically, quality was always a trade-off. Writing comprehensive tests takes time. It costs money. It delays the release. So when push comes to shove, we cut the tests.
We'll fix it in post, the classic line.
Exactly. But for the AI, generating 68 tests costs the same amount of effort as generating 0. It's just a few more tokens.
So the economic excuse for bad code it evaporates.
Completely.
Yeah.
And it didn't just write, does it work tests. It tested business logic. Minimum salary cannot be higher than maximum salary. You cannot apply for a job with a start date in the past. It covered every single edge case defined in that 1,000-line spec.
That fundamentally changes what we consider an MVP, a minimum viable product. Usually MVP is just code for it's kind of broken, but it works enough.
Now, MVP just means feature limited. It doesn't mean quality limited. You can have a small feature set that is absolutely bulletproof from day one.
I want to zoom out a bit. We've talked about the developer experience, but what does this do to the team dynamic? Specifically, that, relationship between engineering and product.
It breaks down the silos. That's the big cultural shift.
How so?
Well, think about that 1,000-line spec. It contains acceptance criteria written in plain English. A non-technical project manager can read that and understand exactly what is being built.
So that solves the classic argument where a PM asks, why is changing this button color taking 3 days?
Right. Usually the dev just says, it's complicated. But now you can show them the spec.
Yeah.
And they can see, oh, changing the color triggers a design system update, which triggers an accessibility validation, which requires updating the mobile tests.
It makes the invisible work visible.
And it creates accountability. This is the traceability point we touched on earlier. If something breaks in production, you don't just stare at the black box and shrug. You look at the plan.
Right. You ask, did the plan fail to cover that scenario? If so, that's on the human for approving a bad plan.
Or, did the AI fail to execute the plan correctly? In which case, it's a bug in the generation, and you fix the prompt or the framework.
It turns the blame game into a systemic debugging process.
The source material suggests this changes the workflow timeline drastically. A planning session that used to take 7 hours of back and forth, it might now take 1 hour.
But that 1 hour yields 10 times the amount of detailed documentation.
Correct. The developer isn't spending their time arguing about variable names. They are spending their time reviewing logic and architecture. It's a much higher leverage use of human intelligence.
It really feels like we are evolving from being writers to being editors and maybe even lawyers.
Code lawyers, I like that. We draft the contract, we check the fine print, and we let the machine do the heavy lifting of execution.
It's a much more mature way to handle these models, isn't it? Instead of fighting the black box or fearing it, you wrap it in a contract.
It turns a ticket into a guarantee. That's the whole promise of spec-driven development.
I want to leave our listeners with a final thought that really stood out to me near the end of the research. It's about the source of truth.
This is the really provocative part.
The sources suggest that if the spec is the absolute truth and the AI ensures the code matches the spec perfectly, are we heading toward a future where humans just stop reading code entirely?
It's the logical conclusion, isn't it? If the contract is strictly enforced by the machine, the source code, the actual Python or JavaScript, it might just become an intermediate layer, like compiled bytecode is today.
Right. I don't read the binary that runs on my processor. I just trust the compiler.
Exactly.
Yeah.
We might reach a point where humans only ever read and write the contract in English. Natural language becomes the highest level programming language. And the code itself is just something the machine generates to talk to another machine.
That is both terrifying and incredibly exciting. It basically means the barrier to entry for building software is about to become your ability to think clearly and write logically, not your ability to memorize syntax.
And it might be closer than we think.
Something to mull over next time you're staring at a pull request. That wraps up our deep dive into spec-driven development. Check the show notes for links to OpenSpec and those original breakdowns from LIDR AI.
Happy specifying.
See you next time.